And finally, we're going to look at adding and subtracting fractions. We'll look at numerical fractions like these, and then in subsequent slides, we'll get into rational expressions, adding and subtracting rational expressions. In any case, for each, the most important thing is that we need a common denominator in order to be able to add and subtract these fractions. So for each set, the first thing that we're going to do is find the LCD, the least or the lowest common denominator, and then we'll carry on. So these steps will be the same whether we're dealing with a numerical example or an algebraic example, a rational expression. There are lots of ways you can use to find the lowest common denominator. What we're really looking at here is finding the lowest common multiple. So you could write out multiples of 3, 8, and 12, the second question of 3, 9, and 12. And that would absolutely work. You're looking for the smallest number that they are each divisible by. Maybe it just jumps out at you and you're not exactly sure why. Maybe you look at the first question, you say, well, the lowest common denominator is 24. And in fact, it is. But maybe it doesn't jump out at you. And perhaps when we get to the rational expressions, it won't jump out at you then either. So let's go through a rigid or a more structured technique for finding the lowest common denominator in any situation. How are we going to do that? Well, first we're going to look at the prime factors for each denominator, because the lowest common denominator is the smallest number that's divisible by each denominator. So I'm looking for the smallest number that's divisible by 3, by 8, and by 12. So let's look at the prime factors. For 3, the prime factors are just 3 and 1. So we'll only write the 3 down, because all numbers are divisible by 1. What about for 8? Well, for 8, we have 2, 2, and 2. 2 times 2 times 2 is 8. Remember that prime values are divisible only by themselves and by the number 1. What about the 12? Well, perhaps for the 12, it's less obvious, and so we'll use a factor tree to find the prime factors. To create a factor tree, first come up with 2 numbers that, when multiplied together, give you 12. 4 and 3 are common guesses. It could be 6 and 2. We'll get to the same answer. 3 is prime, so we'll stop there, but 4 is divisible by 2. 2 times 2 is 4. So the prime factors are 2, 2, and 3. Try it. 2 times 2 times 3 is 12. So 2, 2, and 3. So the lowest common denominator, in order to be divisible by 3, has to be composed of a 3. So we'll add a 3 to it. In order to be divisible by 8, it has to be divisible by 3 2s all at the same time. So we'll make sure that we have 3 2s in the lowest common denominator. So I'll take our 3 and multiply it by those 2s. In order to be divisible by 12, we need to be able to divide the LCD by 2 2s and a 3. But we already have 2 2s and a 3 in the lowest common denominator, so we don't have to add anything additionally to ensure that the LCD is divisible by 12. Now all we do is multiply that out. 3 times 2 times 2 times 2, or 3 times 8, is 24. So we find that the LCD is 24. I'm going to erase some of this thought process, this thinking, so that we can carry on and solve the problem. But we'll follow those same steps to find the LCD in each case. All right, so our next task is to write equivalent fractions for each existing fraction. So a fraction that's equivalent to 2/3 but has a denominator of 24. Then a fraction that's equivalent to 3/8 but with a denominator of 24. And of course also a fraction that's equivalent to 5/12 but with a denominator of 24. So one way we can do this is to write an intermediate step. It's a little bit formal. And maybe you're skipping right to the answer, and that's absolutely fine. My question here is, how do I take 2/3 and turn it into a fraction that has a denominator of 24? So what I want is a new fraction with a denominator of 24, currently have a denominator of 3. How do I turn a 3 into a 24? I multiply it by 8. If I multiply the denominator of a fraction by 8, I have to multiply the numerator as well, right? I can multiply a fraction by anything I'd like, as long as the denominator and the numerator are the same, as long as I'm multiplying by 1. So here, 3 times 8 is 24, and 2 times 8 is 16. And you can verify for yourself that 16 over 24 is equivalent to 2/3 by reducing 16 over 24 to 2/3. We'll go quite slowly at the beginning, and then we'll speed up this process as we go on. Oh, so that's not 3/4. We should draw this as 3/8. And we need to turn that into a fraction also over 24. So what do we need to multiply top and bottom by to ensure that we have 24 as a denominator? Well, 8 times 3 is 24. So we'll multiply the bottom and the top of this fraction by 3. 3 times 3 is 9. 9 over 24 is our fraction that's equivalent to 3 over 8. And then finally, 5 over 12. We'd like a fraction again that has a denominator of 24. What do we need to multiply by in this case? Well, 12 times 2 is 24, so we'll multiply the top and the bottom of this fraction by 2. 5 times 2 gives us 10. For each step, this will be the most involved. For each problem, this will be the most involved step. After this, things are fairly straightforward. As soon as I have that same denominator for each question, I only need to write that once, and then I'll do the arithmetic. I'll take 16, subtract 9, and add 10. So you could write it this way, or you can just write the final answer. 16 minus 9 plus 10 is 17. So we get a final answer of 17 over 24. Quick check, can I simplify this fraction any further? 17 is prime and doesn't go into 24, so this is the final answer in simplified form. So I encourage you to try this same method for the second problem. Even if it feels a little bit uncomfortable to begin with, let's apply those same steps here to find the lowest common denominator and then to write equivalent fractions. Okay, so this time our denominators are 3, 9, and 12. Writing those out as prime factors gives us 3. 3 times 3, and 2 times 2 times 3 is 12. So we discovered the prime factors in the last problem. Therefore, what has to be in my LCD? Well, to be divisible by 3, I need a 3 in my LCD. To be divisible by 9, I actually need 2 3s at the same time. I already have 1 in the LCD, but I will have to multiply that by a second. And finally, to ensure that my LCD is divisible by 12, it needs to contain a 3, and it does, but it also needs to contain 2 2s. So I'll add those in. 3 times 3 times 2 times 2, 9 times 4 is 36. 36 is the lowest common multiple, and because we're adding fractions, we'll call that the lowest common denominator. All right, what's our next step? We found the LCD, and we're looking to add these fractions, add and subtract these fractions using the LCD. So our next task is to write equivalent fractions for 1/3, 4/9, and 7/12, all with that same denominator. So I'll set it up quite quickly for us. So we're going to take 1/3, 4/9, and 7/12, and we'll have to find what we need to multiply top and bottom by to get to 36. Well, 3 times 12 is 36, so we multiply the top and bottom of the first fraction by 12. 9 times 4 is 36, so multiply the second fraction top and bottom by 12, and 7 times 3. Okay, now we simply have to do that arithmetic. 1 times 12 is 12, 3 times 12 is 36. For the second term, 4 times 4 is 16, 9 times 4 is 36, and 7 times 3 is 21, so we have 21 over 36. As soon as I have common denominator, I only need to write my denominator once. Then my question is really, what is 12 plus 16 minus 21? Find 7 over 36. Again, I can't simplify this fraction, so there we have our final answer. Let's look at one more completely numeric example before we look at one that's starting to have some variables in it before we move on to the final type of problem that we'll look at. Again, let's find the lowest common denominator. We'll do that by finding the prime factors. Prime factors of 21 are 7 and 3. For 15, they're 5 and 3. And for 35, they're 5 and 7. Kind of an interesting one. So in order to be divisible by 21, the LCD must have a 7 multiplied by a 3. In order to be divisible by 15, it must have not only a 3, but also the 5, so we'll add that in. And to be divisible by 35, it needs both a 5 and a 7, which it already has. So it only needs one 5 at a time. It either is going to be divided by 15, or it'll be divided by 35. These don't happen at the same time, which is why we only need the one 5. 7 times 3 times 15 is 105. So here we find an LCD. And of course, for a numeric example, you don't necessarily need the lowest common denominator as long as you have a common denominator. You'll be able to simplify the problem at the end. Once we move into the algebraic examples, though, it'll be much more difficult to simplify the problem. So you do want to make sure you're using the lowest common denominator to save you steps later on. And in fact, we haven't yet learned the tools we'll need to simplify the problems. So it's critical that we find the lowest common denominator, not just any common denominator. I'll set the problem up similarly to the last one. So we know we have each fraction that we'll have to rewrite as an equivalent fraction that's divisible by 105, or rather that has a denominator of 105. So it's sometimes nice to set up a structure for your problem that you just have to fill in. It's one way to ensure that you have all of the pieces. Okay. So one thing I'll just remind you of is that the LCD came from 3 times 5 times 7. So we can really think of this as, well, 21 was 3 times 7. Which factor is missing in this case? And it's the 5. 21 times 5 is 105. The other way, of course, to come up with S5 is to say, what is 105 divided by 21? You'll still come up with that 5. So we have negative 20 in the numerator and 105 in the denominator. If we have the 15, well, we already have 3 and 5, part of the lowest common denominator, but we're missing the 7. So we'll multiply 15 by 7 to get to 105. If we multiply the bottom of the fraction by 7, we certainly must multiply the top of the fraction by 7. And 6 times 7 is 42. And finally, we have 35. That's composed of the factors 5 and 7. We're essentially missing 3. Let me try to straighten that up a little bit. Okay, so we have, I'd written a positive here, but of course we are subtracting the third fraction, and the numerator is negative 1 times 3, or negative 3. That's the hard part done. Regardless of what the problem looks like, this will be the most involved step. Finding the LCD and then using it to write an equivalent fraction. Once we're there, we only need to write the denominator once, and then again, you can probably hear me typing on my calculator. We'll just do the arithmetic. We have minus 20, and we'll add 42. So minus 20 plus 42, which you can probably do in your head as well, and then we'll subtract 3. We end up with 19 over 105. 19 is prime, 105 isn't divisible by 19, so I know that we can't simplify that fraction any further. So 19 over 105 is our final answer.